So today we're talking about section 14.1, and this is the fundamental counting principle. So this is basic probability here. The key here is when two events occur in order, you can multiply them. I'm going to show you why that's true. So we'll take a kind of a typical question here. Sub shop, you have three choices of bread. So you first, you choose your bread. So you have a choice of three breads. So I'm going to draw a tree diagram. These are branches of the tree to indicate your three choices. So maybe one of these is rye bread, white bread, and wheat bread or something like that. You have three choices of bread. Then you have a second choice you have to make your sub. There are four different kinds of meats to do. That one in blue. So from each one of these choices, you now choose 1, 2, 3, 4 meats. 1, 2, 3, 4 meats. 1, 2, 3, 4 meats. And then at that point, you choose any one of two cheeses. So after you've made those two choices, you're now making another choice. So there's more branches, but it's hard to draw. Should have done less. Wow, each one of these gets two branches. I'm running out of room. Wow. Okay, so each one of those has two branches, and then finally, oh, that was it. Okay, so if you pick the end of these, so count up how many of these there are. If you count all the ends of the branches there, it would be 24 different options there. So the fast way to get there is to use the counting principle. Say, well, let's just do 3 times 4 times 2. 12 times 2 is 24. I think that's a little bit faster. The concept behind it is this idea of a branching tree. So you have 3 branches. Each one of those has 4 branches. That's like multiplying by 4. And then each one of those has 2 branches. That's like multiplying by 2. So you get the answer of 24. And that's a very fast way of getting it. So now we're getting into probability here. So we're going to use this idea to talk about two different types of license plates. So back in 1912 in Maryland, you had digits, and there were 4 digits. So let's kind of draw those out. Let's use the fundamental counting principle here. So we're going to multiply these numbers here. How many different options are there for number of license plates? So for the first digit, it could be any digit, 0 through 9. Sometimes when students see that, they think, oh, there's 9 digits. There's actually 0 counts as a digit, not just 1 through 9. So there are 10 possible digits. Second digit can be anything. There's no rule about repeating, so we're going to assume repeating is okay. Third digit's 10, fourth digit 10. It looks like there's going to be one with 4 zeros. So 10,000 different license plates were available in the year 1912. Now that's not enough for current times. And so in 2007, they had 3 letters and 3 digits. A lot of states are kind of like this. They have kind of 3 letters and then 3 digits. And so let's think about the possibilities here. So I kind of call this slot method, but it's using the counting principle here. So we're going to multiply how many different letters are there for the first letter. It could be anything, any letter, so 26 letters. It doesn't say repeats are not allowed. So there's 26 here, times 26, times, and then first digit, there are 10 digits, so 10 times 10 times 10. Type that in your calculator, get your answer. That's how many possibilities. And it's probably in the millions here. It's quite a bit. And so then you choose your calculator at that point. This one's a little tougher. Now, lock has 12 positions, and you probably have these kind of locks, and they turn clockwise and then counterclockwise and then clockwise again. But this is the interesting part of this question. Is successive numbers, the combination cannot be the same. So there is a stipulation that makes this into a tougher problem. We're going to really have to think how many different combinations are possible. I've got 3 blanks here. I've got to think through. They're going to be multiplied by each other. But this is really a big deal. So let's think about that for a second. So if we've got, like if my first number was 8, and my second number was 5, my third number, could it be 5? Is that possible? That's a successive number. That's a number in a row. Two numbers cannot match in a row, cannot be successive. I could have that at 8. That's okay, right? It could be any other number, but that number can't be 5. So let's think through this. So the first digit can be anything. There are 12 possibilities. There's 12 positions on the log. Second number could be anything but the first number I chose. So if I chose an 8, the second number could be anything but an 8. It could be a 5, a 6, a 7, just not an 8. So there are 11 options there. And once I've chosen that second number, so I chose an 8 and a 5, we just established you cannot have that third number match the second number, just like the second number can't match the first number. There are only 11 options available once you've chosen that second number. So whatever that is would be your answer for this one. 12 times 11 times 11. Use your calculator, and that's how many different possibilities there are. How many ways can a president, vice president, and secretary be chosen from a class of 30 students? So interesting here. Now when you're choosing 3 positions, and the question that's kind of behind the question here is order important? And I think order is important in this question. I think these positions, president, secretary, vice president, those are 3 positions that are distinctly different. Usually people want to be president, then maybe vice president, then maybe secretary. And so when order is important, we can use this kind of slot method, this kind of counting principle idea. And so there's 30 options for the first 30 ways that you could choose the president here, and then the VP, and then the secretary. So once you've chosen the president cannot also be the vice president, right? So you've eliminated one of the choices. You started with 30 students, you've chosen the president, and now you only have 29 left. A lot of runoffs actually do that. They try for president, and if you don't get it, you might run for VP. And then once you've chosen the president and VP, you only have 28 positions left over. So whatever that is would be the number of ways that you can choose a president and vice president. So here we have 5-letter palindromes. So if you don't know what a palindrome is, like a palindrome is like race car. And it's a palindrome because you can go forwards or backwards. R-A-C-E-C-A-R, R-A-C-E-C-A-R. Spells the same word forwards and backwards, just like AMTMA does. Now, for this type of palindrome, that's not a word, right? We know AMTMA is not a word, but it is a palindrome, or at least the form of a palindrome. So assuming it doesn't have to be a letter, it's just a string of, it doesn't have to be words, it's just a string of letters that's the same backwards and forwards. How many different 5-letter palindromes? So we have 5 letters that we're choosing from here. And not just those letters, but we're choosing from any letter. So they could be any letter. So the first letter could literally be any letter in the alphabet. There are 26 possibilities. According to this, AA would be a palindrome, right? It doesn't say there can't be repeats. So I think that second letter could be anything. And that third letter could be anything. But it does say it has to be a palindrome. So to be a palindrome, I don't think this letter can be anything. Once you've chosen the first 3 letters, this letter is always going to match this letter, right? Just like the C and C match, the A and A match, the R and R match there. So there's only one option available for that letter because it has to match this letter. Same thing here. This letter has to match this letter, so there's only one option available. So to find the total number of possible palindromes, you would multiply 26 to the 3rd power. For St. Mary's, enter a cake ball eating contest. There can be no ties. How many final results are possible? There's only 4 students, so we've got 4 spots here. How many students could get first place in this contest? There's 4 options. Once you've decided first place, there's only 3 options left. And then 2 options left after that, and then 1. And 4 times 3 is 12, times 2 is 24. There's actually a faster way of doing this, and we're going to learn more about this in coming lessons, but you could do this by just saying 4 factorial. That's what 4 times 3 times 2 times 1 is, just like 3 factorial is 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. So factorial kind of works like that. The shortcut we'll learn about later. How many 3-letter passwords can be formed using the 26 letters of the alphabet if repetition is allowed? So we've got 3-letter passwords, 26 times 26 times 26. What if they said that this was not allowed? Repetition is not allowed, that all of a sudden this would be 25, and this would be, that should have been 26, by the way. This would be 24. The original problem, it should have been 26 right there. Sorry about that. 26 to the third power would be the answer, and in the second problem, where repetition is not allowed, it would be 26 times 25 times 24. Telephone numbers have 7 digits. The first digit cannot be 0 or 1. That's actually true. The first digit of your telephone number cannot be 0 or 1. How many telephone numbers are possible? So you've got 7 choices here. First digit is limited. You cannot have 10 different options. There's only 8 options there. Second digit really can be 0 or 1. There's really no limitations here, so there'd be 10 times 10, times 10, times 10, times 10. These are all 10 options there. Only the first digit has a restriction on there, so it would be 8 with that 1, 2, 3, 4, 5, 6 zeros. So there are 8 million possible 7-digit telephone numbers available, which is why we actually have 3 more digits, like an area code. In fact, some larger cities even have different area codes in the same city. So Memphis is mainly just 901. That's the end of the lesson.